Joy Zeigler here, and we're going to start part 4 of the Exam 5 review for Math 310. The first problem is to simplify this radical, and it's a cubed root. So what we want to do is find cubed roots inside numbers that are perfect cubes that we can pull out of the radical. So we can see right away that 27 is 3 cubed. X to the 9th, well, we divide 9, the exponent, by 3, the index, and we get x cubed. If you multiply the two exponents using the power rule, you get x to the 9th, and y to the 12th is y to the 4th cubed. Again, 12 divided by 3 is 4. So what we have is, we have the radical, cubed radical of 3 cubed, x cubed, all of that cubed, and y to the 4th, all of that cubed. So that means we can bring out 3, and then we can bring out x cubed and y to the 4th. And there's nothing left inside the radical, so that's our solution. To simplify this radical, we break up numerator and denominator, and we're dealing with square roots here. We know that the square root of 36 is 6, and in the numerator we look at 10, and our index for a square root is 2. So 10 divided by 2 is 5, so we have v to the 5th squared. To check that, multiply the exponents together and they should equal 10, which is what we started with. So the square root of v to the 5th squared is simply v to the 5th. So we have v to the 5th over 6 as our answer. In this problem, we know that the square root of -4 is the same thing as the square root of -1 times 4. And the square root of -25, same thing. We have -1 times 25. And the square root of -1 is I. The square root of 4 is 2. Square root of 25 is 5. So we have 10i squared, and I squared is -1, so we have -10. Here we have a negative radical to resolve. Don't worry too much about this negative sign outside of the radical. We won't be operating on it. We're just going to carry it all the way through to the end, and then if there's something to deal with, we'll deal with it then. Okay, the square root of 196 is 14. So we have negative square root of 14 squared, and that's also -1 for that negative sign. So that's going to be -14 times I, because the square root of -1 is I, and that's our answer. Okay, in this case we have to find out what value m is in order to make this true, this equation true. So to get rid of the radicals, we're going to square both sides, and that leaves 5m minus 16 equals, we're going to do 2 squared, which is 4, and the square root of m squared is m. So let's subtract 4m from both sides, and we get m minus 16 equals 0, and after we add 16 to both sides, we get m equals 16. But in a problem like this, we might have an extraneous solution. So we need to check our answer, and so when we do that, we're going to plug in 5 times m, which is 16, minus 16 equals 2, and that should be square root of 16. Well, 5 times 16 is 80, minus 16, and 2 square root of 16 is 2 times 4. 80 minus 16 is 64, and the square root of 64 does equal 8. So this checks, and that means that our solution set is 16. Okay, 81 to 3/4 power. We're going to convert that into radicals, and that's going to be the 4th root of 81, all of that cubed. Okay, the 4th root of 81 is 3, and that's one of the things you ought to be familiar with, but you can just take your calculator and say, is it 2? Well, you know it's not 2 because it's not even. Is it 3? So multiply 3 by itself 4 times, and you'll get 81. So you know the 4th root of 81 is 3, and we still have this exponent 3 there. So to do that a little slower, you would say the 4th root of 81 is 3, so you would say 3 to the 4th is 81, all of that cubed, and then the 4th root of something to the 4th power is just the radicand, and you still have the cube there. Okay, so 3 cubed is our answer because we're going to leave it in exponent form, and there's nothing else we can do about it. The only exception to this is if the problem actually asks you to express it without using exponents, in which case 3 cubed would be 27. The last problem on the review is to find the square root of 72. Now, to find the square root, we know that 9 times 8 is 72. And what we want to pull out are perfect squares. So we have the square root of 9 times the square root of 8. So the square root of 9 is 3, but the square root of 8, do we have a perfect square there? 8 is 4 times 2, so that's going to be the square root of 2 times the square root of 2 squared, which is 4. And so that is going to equal 2 square root of 2. So bring this down, and we have 3 times 2 square root of 2 equals 6 square root of 2. Solve the cube root of p minus 7 plus 4 equals 0. First we want to get the radical on the left side of the equation, so we subtract 4 from both sides. And we know that the cube root can be a negative number, so p minus 7 equals negative 4 cubed by cubing both sides of the equation. And so p minus 7 equals 4 cubed is 64. A negative number cubed is negative, so we get negative 64. And then we add 7 to both sides, and we get negative 57. It's always good to check your work. So we're going to plug in negative 57 into the original problem, and that would be negative 57 minus 7 plus 4 should equal 0. So that gives us the cubed root of negative 64 plus 4 should equal 0. And the cube root of a negative number is a negative number. The cube root of 64 is 4. And negative 4 plus 4 does equal 0, so it checks. Now remember, when you're working your test, you want to write out all of your cubes to maybe 5 or 6 cubed. So you can do this by plugging in 3 times 3 times 3 in your calculator and so on. But then when you're working a problem and you get to this point in a problem, you can just glance, whoops, I meant 64 there. You can just glance over at your table and see that the cube root of 64 is 4. Express the radical in a simplified form. So our goal here is to see if there are any perfect square factors of 1700 and then take the square root of those perfect squares. The negative sign has nothing to do with the square root of 1700, so it's just going to be carried down. And we know that 1700 is 17 times 100, and that's equal to negative, and then you can break that up like this, and to take it to all of its steps, 100 is 10 squared, and the square root of 10 squared is 10. We put that in front of the radical, and that's the result. That's the end of your exam review. I recommend that you make sure to do several practice tests, and if you get any wrong, go to the study plan and select Chapter 17 and do the problems that are indicated with thumbtacks so that you can work on the problems you got wrong on the practice exams, and then take the practice exams again to make sure you've learned the concept. Do well on your exam. Make me proud.